Hello and welcome to another episode of Mr. Walker's APES. We're still in the Living Systems unit, and to go along with the Living Systems unit, we've got to learn about the biogeochemical cycles. I will go ahead and start by saying that this is one of the harder things for AP students to learn, primarily because it's really memorization of these processes. These are processes that have been studied for decades by environmental scientists and ecologists and geochemists and things. The problem is, of course, that we don't have decades to study these and how they really work in the environment. But there are some key things that I can help you that remember that should make these a little bit easier. Okay, some of these you're going to have seen before, of course. These are the 5 cycles that you must know for the AP exam and for my exams. All right, the water cycle, carbon cycle, nitrogen cycle, phosphorus cycle, and sulfur cycle. Now, of course, water you probably have had at some point in your school years. Carbon, maybe, in biology, but nitrogen, phosphorus, and sulfur, this might be your first time seeing them. So please pay attention. If you think I'm going too fast or something, just pause the video and take a minute to study these. Also, it would be very helpful if you draw all the cycles. Even though I have them as images, it would be helpful to your own studying to draw them yourself, and then try and draw them later after you have studied before the exam and see if you're able to do it. So the first thing, the hydrologic cycle or water cycle. Okay, anytime you see hydro, we're talking about water. So here it is in all its glory. You know, the basic. Okay, if you just remember the basics, you'll get most of this. Okay, so you can start anywhere in a cycle. Let's start with rain or precipitation. Okay, precipitation includes snow and rain and ice and anything else that falls from the sky as water. So if we start here, okay, basically water hits the land. All right, so we're going to hit the land, and then ultimately that water ends back in the ocean or some other surface water body like a pond or river or lake, and it evaporates back into the clouds where it precipitates again. All right, so that's the gist of the cycle. However, we've got a lot more than that to learn about in this class. If that were it, you could take this exam in 3rd grade. So, what are some other key terms? What are some other things that we need to learn about with the hydrologic cycle? All right, so if we start back with precipitation, notice at the beginning I said precipitation is anything that's water that falls from the sky. This could be ice, snow, sleet, rain. Okay, all of that is precipitation. So be careful on exams. If they say rain, they mean liquid water falling from the sky. If they say snow, they mean frozen water falling from the sky. If they say precipitation, they could mean either. So you need to be careful with those words. So if it falls as snow, well, it has to melt first. Okay, once it melts, then you treat it just like rain, and it's going to run off of the surface. So we have the surface runoff, which goes into ponds, into oceans, into rivers, into streams, etc. Some of it, however, will get into the groundwater, so it will infiltrate the ground and get into groundwater, which can then either upwell into a pond, river, lake, stream, okay, or can just discharge into the ocean. Around here, we have lots of rivers and we have lots of ocean nearby, so it could go either way. In the middle of the country, it either will stay as groundwater or show up as a river or a lake. Okay. Once it's in the body of water, then it will either be taken up by plants or evaporated into the air. If it evaporates, then it's just because it gets hot enough that the water leaves the surface, the water droplets leave the surface of whatever water body it's a part of and gets into the air. If it goes into a plant, the plant will use some of the water and it will release some of the water. And when it releases that water and then it evaporates, we call that transpiration. So transpiration is through plants. So transpiration, that's your plants. Okay, then once it's in the air, either by transpiration or evaporation, once it gets cold enough, so at high altitude, it gets colder. So those water droplets condense into clouds. So anytime you see condensation, think clouds. All right. And then, of course, the water is stored in the clouds, and it comes back over here to precipitation. And on you go. Okay, so not a really hard cycle, just a lot of new vocabulary words to keep in track of. Helpful ways to remember this. Pretend you're a water droplet. Start where you want to, and imagine your journey. Where might you go? Make it fun too. Maybe you end up evaporating out of the Atlantic Ocean and raining over Nepal, and then running off of a glacier into India. Make it fun. Imagine where you want to go. So of course, because this is environmental science, we need to study how humans disrupt this cycle. So, again, the vocabulary words, we've already gone over these. I'll leave it on this slide for just a minute just so that you can take the time to write them down. Alright, I'm going to move on. If that wasn't enough time to write them down, just pause the video. So, again, it is AP Environmental Science. So how do we disrupt this hydrologic cycle? How do we disrupt the water cycle? Write down one or two ways. We'll discuss these in class. Alright, carbon cycle. Okay, carbon cycle is how does carbon, the element, cycle in the environment. Now, what is carbon mostly in? Well, it's CO2 primarily. Okay, carbon dioxide. That's primarily what we're really talking about here. There is a little bit of methane as well. That's CH4, carbon and 4 hydrogens bonded together. But really, it's mostly CO2. So, how does it work? Okay. Again, it's a cycle. Pick anywhere. All right. I like to start with animals, really, because we are animals, and it's easiest to think of it that way. So, how do animals factor into this whole carbon cycle? Well, obviously we breathe out CO2, so that's animal respiration. So we're going to breathe out some CO2, which goes into the air. We also store carbon. All right, as we grow and become mature, we store more and more carbon in our systems as we build more cells and more tissue. So once we die, all right, then that carbon that we've stored goes into the ground. So if you start with an animal, you either breathe it out and it goes into the air, or you die and it goes into the ground. So we'll go from the air next. Okay, so if we've got CO2 in the air, obviously plants use that to do photosynthesis and build sugars. So the CO2 goes into plants, where with sunlight it undergoes photosynthesis and becomes sugar. The sugars can go into animals. Also, the plants use some of it, which goes back into the air. So that's kind of a miniature cycle right there, where I'm respiring, going into the plant, and then back out. So that's kind of a little miniature cycle. Also, the plants respire themselves, so that's within there's a cycle as well, where the plant is possibly breathing out the same CO2 that it breathes in. Okay, and of course, plants die as well. So when they die, okay, you've got dead organisms and waste products. Okay, animals and plants die. when animals and plants die, over time they lock that carbon into fossils and fossil fuels. We burn carbon in all fossil fuels, whether it's coal, natural gas, oil, and that's it. Then you're going to have some type of carbon from dead animals millions of years ago. So the oil you burned in your car today is from plants and dinosaurs. Maybe 60 million years in the future, the oil that they burn will be from us. Who knows? All right. So then, of course, those fossil fuels and even plants go into factories where they are burned. And then, of course, they are burned and sent into the air again. So this goes back over to here and so on. Now you notice there's this little word in the bottom here that says ocean uptake. And there's not an arrow going to it or anything. Ocean uptake is when there's CO2 in the air and it goes into the ocean. It gets stored in the water. So this is, you've got soda. The very first ingredient on all soda water or soda like Coke is carbonated water. And that's kind of what happens with the ocean, but obviously not to the extent that you have in Coke. The ocean doesn't bubble like Coke does. But it does take in quite a bit of CO2. And we'll get more into this later, but one big concern right now for the planet is how much CO2 can the ocean take up? And if it takes up too much, how's that going to affect the life that lives in it? So that's a concern for environmental scientists right now as we begin to study the carbon cycle quite extensively because of the threats of global climate change and global warming. Okay, so again, in your notes, write down 1 or 2 ways that humans disrupt the carbon cycle. These are all completely natural cycles that have been ongoing for millennia, and now we're beginning to disrupt them. So think of 1 or 2 ways that we disrupt the carbon cycle. Now we have the nitrogen cycle. This one is probably the hardest of all the cycles because there's a lot of words here that are very confusing. All right. So, where to start? Let's start anywhere, I guess. Let's start down here with soil, clay minerals. Clay minerals can fix or unfix nitrogen. What I mean by fixing nitrogen, I mean hold it. They hold it in place. Okay? So if I have some clay in my soil and it's fixing nitrogen, that means it's hanging on to nitrogen and not allowing it to get into the air. And that's okay. All right? But however, the clay minerals can weather. And when they weather or they come in contact with certain types of chemicals or things, they will release the nitrogen. And they release the nitrogen in the form of ammonium. Ammonium is NH4. Okay? So anytime you see NH4, that's ammonium. It contains nitrogen. All right? And from ammonium, we go to nitrates, or nitrites rather. Nitrites are NO2. Okay, this is a natural process that occurs where some of the hydrogens will get cut off and oxygen will be added. All right, and now here's where it can get kind of confusing. So I'm going to follow this upper path first. All right, nitrification through bacteria. This is going to confuse you guys because you can see we're going from nitrite to nitrate. And the only difference was that I added an oxygen. Well, nitrification, that sounds like I should be adding nitrogen, right? That's what it sounds like to me. So you have to break that. You have to break that kind of relying on the word to help you out here. nitrification is when bacteria add oxygen to nitrogen. And what this does is it causes it to be more fixed in the soil. In other words, plants can't use it, and it's not going to go into the air. Okay, so it's stuck in the soil a little bit better. It's fixed. So nitrification fixes nitrogen in the soil. Then it can undergo denitrification. Denitrification is when we turn it into N2. This is the stuff that's in the atmosphere. All right, so recap. You've got some nitrogen in the soil already as ammonium. Ammonium turns into nitrite. Through nitrification by bacteria, we produce nitrates. And then some bacteria, some natural processes will break down nitrate into nitrogen, N2. We call that denitrification. The N2 can then go into the air or be absorbed by plants. All right. Also, the NO3 can be absorbed by plants. That's a nutrient that's common in fertilizer, nitrate. So we've got all these processes going on. So we're halfway through the cycle here. Once we get over to this other part of the cycle, all right, so now we get organic residues, either, cow pies or dead leaves, things like that. Those are your organic residues. Become organic matter, which is when it breaks down a little bit, becomes more soil-like. Once it's more soil-like, it can be mineralized. Mineralization means it becomes more rock-like. It strips off all the carbon. It gets rid of all the stuff that is organic, and it makes it inorganic. So, or inorganic nitrogen can become ammonium, which then follows the rest of the cycle. Now over here we have leaching. The term leaching means to leave the soil or go down through the soil. So both nitrites and nitrates can leave through the soil. They will dissolve in water when it rains, and that water will carry the nitrogen out of the soil and into the groundwater. Okay, take a minute to study this one. Remember, you can always draw over this stuff. Let me just erase all this so that we can see the main point of it. Okay. So, pick a spot, start there. Imagine that you're a nitrogen atom. What's going to happen to you? How are you going to move through this system? There's another way to look at the nitrification cycle, or nitrogen cycle. All right. Notice it's basically the same. Organic residues to organic matter to ammonium to nitrate, which undergoes nitrification to become nitrates, which then either go to plants or undergo denitrification, which becomes nitrogen, so it goes out into the air. The reason precipitation and lightning are shown here. Precipitation, rain can combine with nitrogen and become nitric acid, which will then hit the earth and add nitrogen to the soil again. And lightning can also cause nitrification. Okay, so lightning strikes will hit N2 and produce NO3. We're going to talk a lot about this, where nitrates are added as fertilizer. Okay, that's something that is a major environmental problem, especially this runoff part. So vocabulary, nitrogen fixation. Okay, what does it mean to fix nitrogen? What's the chemical process? So let me write that one in for you. That's a little bit harder one. So nitrogen fixation is when you have NO2 nitrate. I'm sorry, nitrite. This is nitrite with an I. Nitrate becomes nitrate with an A. Okay, that's what fixation is. It's this chemical process. NO2 goes to NO3. So don't get that one too confused, okay? Ammonification. Okay, ammonification is when I have organic waste. Let me just abbreviate here. So I'm going to have organic waste, so OW goes to organic matter, OM, goes to ammonia, which is NH4. All right. This is probably where you're starting to see in this class where chemistry will help you out quite a bit, and it gets better. So if you're not understanding the chemistry, if you don't remember this stuff, please come see me so that we can make sure that you're up to speed on your chemistry. All right, so then nitrification. Nitrification is when you have nitrate with an A going to N. Or I'm sorry, wait a second. No, these. Ugh. See, even I get confused. Okay, nitrification is very similar to nitrogen fixation. Okay. The fixation is, of course, when it gets put into the soil. This is going to be basically the same thing, the nitrification. NO2 goes to NO3. Denitrification is when you take that NO3 and you go to N2. And this goes into the air. And this will either go to plants or soil. Okay, so my apologies there. I had to take a second and think about it. So it is easy to mix these words up, so please pay attention to the word and make sure that you have them straight in your brain. So ammonification, organic waste, like cow pies, becomes organic matter, which is in soil. It's the dark stuff in soil, which becomes ammonia, NH4. The ammonia breaks down into nitrite, which undergoes nitrification by bacteria to become nitrate, which is then taken up by plants or held in the soil. Over time, denitrification and some bacteria will cause denitrification, where NO3 becomes N2, which makes up 78% of the air. Alright, so that's your nitrogen cycle. So once again I ask, how are humans disrupting the nitrogen cycle? Remember that nitrate is a major part of fertilizer. And think about, what happens when we sterilize soil. How does that affect the bacteria that undergo some of these processes? Things like that. Alright, phosphorus cycle. Phosphorus cycle is not as complicated as the nitrogen cycle. The phosphorus cycle, main thing here to remember is that phosphorus comes from rocks and nothing else, really. Either you mine the rocks for phosphate, or over time, natural weathering causes phosphorus to come out of the rocks. Our main concern is phosphate. Phosphate is PO4. So phosphate is PO4. The reason we're concerned with PO4 is that PO4 is a major water pollutant, and it pollutes water because it's a nutrient that algae use. And without enough phosphate, they don't grow to exceedingly high population numbers. They just grow normally to a healthy number. But as soon as we add extra phosphate to the water, then the algae bloom. And when they bloom, that means that there's too many algae. And they block out the light, which has obvious implications for plants that live in the water. And of course, there are other problems with that as well. We'll get more into those when we talk about eutrophication during water pollution. All right. Plants also use phosphate, so this is for algae, which are single-celled plants more or less, and plants. And it all comes from rocks. So rocks to phosphate to algae to plants. Once those algae or plants die, then it can get put back into the rock and the cycle starts over again. Okay. Phosphate is the major limiting nutrient for algae. Just saying that now so that it can start to get put into your brain. And do note that it has to go into so then these guys come back around to the rock, basically. These die and then go back into the rock. So that's your cycle. Rock to phosphate into algae or plants, back around to rock when they die. So think of ways that we might disrupt the phosphorus cycle. If you need to go back to that diagram and see some of the ways that we help put phosphate into the environment, you can. Think about some of the other things that humans might do to disrupt this. And last, our sulfur cycle. Alright, so sulfur cycle is similar to the phosphorus cycle. It's a little bit different, okay, in that we have an atmospheric component. Phosphate is not found in the atmosphere, whereas sulfur is found in the atmosphere, mainly because of burning of fossil fuels. It wasn't found in the atmosphere in high amounts until the Industrial Revolution. Alright, let's start up here with light. So this is HV, which is just a physics denotation for light. So light hits the atmosphere, and when you have light plus rain, you end up with sulfuric acid, which rains onto the earth. Also, over time, sulfur will just fall down as particles onto the earth, things like ash from coal burning power plants, things like that. And then the sulfur hits the earth. Once the sulfur hits the earth, it gets into the soil, which sulfur is an ingredient for plants, a nutrient for plants. They must have sulfur. Of course, once it's in the plants, then the plants die, they get buried, it comes up through volcanoes, and back into the plants. So this is kind of like the whole rock into sulfur into plants, back into rock, just like the phosphate. The only difference is that we have to include this atmospheric component, where you also have sulfur coming out of the air, because humans burn the quote-unquote rocks, such as coal, and that puts the sulfur into the air. So think of some ways that we're disrupting the sulfur cycle. I've really given you one, because I told you that sulfur is not naturally occurring in the air. So how are we affecting it by putting sulfur into the air? Okay, so there are your 5 cycles. Hydrologic, or water, carbon, nitrogen, phosphorus, and sulfur. Think about all those. We can discuss these disruptions in class. Be sure that you have them written down, and as you're studying for your upcoming exams and quizzes, try and draw each of the cycles. Okay, you don't need fancy, you don't need to draw in a deer or anything, but just draw what is the process. Can I connect all the dots? And that's it. So I hope that you learned something this time, and I'll see you next time.